In this lesson, we will be looking at quadratic functions, otherwise known as parabolas. They give us a curve right here, and as you can see, they are symmetrical, meaning that they are the same on one side as the other. We have some equations that we write. The quadratic function in general form is f of x, which is another thing for y, is ax squared plus bx plus c. Very much just like the quadratic equations we've been solving. We set those equal to 0 and solve for x using factoring or the quadratic formula. Quadratic meaning x squared. A more useful form is what's called the standard form. You may be familiar with the letters H and K. We use those as the center of the circle. Now on parabolas, we're going to be using those same letters for the vertex of our parabola or our quadratic function. It's our turning around point. It's also the point that kind of chops it right in half. So in this instant, our vertex would be 0, 0. We also have what's called that axis of symmetry, the line that goes down the middle of our parabola. That is a vertical line. Vertical lines have equations in the form of x equals some number, and the number in this case would be the h value of our vertex. What I want you to concentrate on right now is this value of a, which is the coefficient of x squared. Let's see how it affects all the graphs. Look at these 6 graphs. On this one, the value of a is 1x squared, and our vertex is at 0, and I went over 1 and up 1, and also the same thing on the left. You cannot continue this process, but only works from the vertex. If a is 2, from the vertex you can go over 1 and up 2, and notice that the graph is somewhat skinnier, if you will. If a is 1/3, over 1 and up 1/3 kind of flattens out or gets wider. What happens when a is negative? Well, it turns it upside down because we're going to go over 1 and now down 1 on each side of our vertex using symmetry. So if a is negative 1/2, over 1 and down 1/2, so again a little bit more flatter or wider than when a is 1 or negative 1. Here a is negative 3, so over 1 and down 3 on each side. And again, you cannot continue that process. You would get a line. That's not what we want. But from the vertex, you can use your value of a to help you graph it. In fact, that's how we're going to graph these parabolas. So how am I going to expect you to be able to graph the parabolas? Well, we're going to look at the vertex. We're going to find a. We're going to plot the vertex, and then from the vertex we're going to go over 1 unit, right and left because of symmetry, and then up if a is positive and down if a is negative. So let's just start with this first example. We have this in what's called standard form, and so the vertex, if you look at that formula, here is h and here is k. So we have 1 and negative 2. Let's just rewrite that formula, a times x minus h squared plus k. Because this has a minus sign, you want to take the opposite, so we have minus 1, so I'm going to put plus 1, but because it's a plus k, we want to keep that same value. So the vertex is 1, negative 2. Now what's a? Well, a is in front of the parenthesis when it's in standard form, which is also the coefficient of x squared. So in this case, it is positive 1. How do I now graph the parabola? From the vertex, I'm going to go over 1 unit, so over 1, and then whatever a is. Since a is positive 1, over 1 and up 1, and using symmetry, I'm going to go to the left. You cannot do that again, and that is a rough sketch of the parabola. You could plot more points, but that is all I am requiring. Now from this graph, I'm going to ask you to find the axis of symmetry. Remember, that's the vertical line that goes through the vertex. And because it is a vertical line, it's the equation of x equals to the x value of the vertex. So our axis of symmetry is x is equal to 1. What about the domain and range? Well, the domain is always all real numbers. Look at the graph. Even though it goes up, it also gets wider. But what about the range? The range, you want to look at the bottom to the top. So the lowest y value is -2, and it's included, and then it keeps going up forever. This -2 is the y value of your vertex. Range is the y value, so there's that relationship. So let's look at this second example. What's the vertex? Again, we want to take the opposite of that in the parenthesis and keep that the same. So opposite, same. So plotting that, -1, -3. That's my vertex. A is again that value, so it's +2. Since it's positive, I know the parabola goes up. How do I graph that? Again, from the vertex, always over 1, always, always, and then whatever A is. And I'm going to do the same thing on the left side. So over 1 and up 2. So this is a skinnier or thinner parabola than the first example. Axis of symmetry, x equals. It's got to be x equals. Don't tell me just a number. That's wrong because it is a vertical line. X equals to -1. The domain is always all real numbers. That's never going to change. The range is the lowest y value to the highest y value. So the lowest y value is -3, and it's included. That's why the bracket. And then it keeps going. So again, this y value corresponds to that y value. Third example, again in standard form. So our vertex, same. I'm sorry, not the same. I made a mistake. What is that supposed to be? That's supposed to be the opposite. So it's +2. And then this is the same. So +2 and +4. So over 2 and up 1, 2, 3, 4. So that's our vertex. Our A is again this coefficient right here. And this time it's negative. So that tells me it goes down. Down. So from our vertex we're going to always go over 1 and then whatever A is. So I'm going to go down 1/2. Over 1 and down 1/2, both sides of the vertex. Again, that's just a rough sketch. It's not perfect, but it's good enough. Then we need our axis of symmetry. Again, it's a vertical line. Don't tell me just a number. It's always x equals to that x coordinate. Domain, all real numbers, that's a given. Now the range, be careful here. Bottom to top. How low does this go? It goes to -infinity. What's the highest y value? It's +4. It's included. So again, this 4 and this 4, there's a relationship. The range goes with the y values. Just be careful here. Remember, we want to go from the bottom to the top. Now we're going to do some algebra, finding the intercepts of a graph. Where does it intersect each axis? Well, first of all, look at the graph. If you can tell exactly from the graph, you don't need to do algebra. So for this one, I know it crosses the y-axis at 5. So the y-intercept would be 5, but there would be no x-intercepts because this graph never crosses this x-axis. And for this parabola, well, I know it doesn't cross the x-axis, but can I really tell exactly what that point is? I can guess, but I need the algebra to help us. So that's why we're going to look at the graph. If you can just tell me the answer, write it down. That's awesome. But if you can't, then we have to do some algebra. So how do we find the intercepts? First of all, this symbol again is the same as y. So in order to find the y-intercept, we're going to let x equal to 0. And that is always the easiest one. You just need to make sure you follow the order of operations. So you're going to do this before you multiply. So you have y equals negative 1/2. Negative 2 squared is positive 4. Then we multiply, and now we add. So the y-intercept is at positive 2. That's the easy one. Now how do we do those x-intercepts? Well, we let y equal to 0. Not as pretty. So we kind of want to get x by itself, so maybe we should start out by getting that parenthesis by itself. What could I do? Well, I could subtract 4. Then that fraction kind of needs to go away. So how about let's multiply by its reciprocal. All right, so that's going to cancel that out. This is going to be positive 8. Looks better. Now we need to go from something squared to not squared. So we need to take that square root. And when you put in a square root that wasn't there to begin with, you must put in that plus or minus sign. And then we need to simplify 8. So our last step is to get x by itself. So I'm just going to add 2 to both sides. Let me come over here. So I'm going to add 2 to both sides. And so that is 2 x-intercepts. Alright, so this problem, I believe, was our third example. So if I come back up here to my third example, here was my graph, and my y-intercept should have been exactly 2, so I was close. And here are my 2 x-intercepts, 2 plus or minus 2 times the square root of 2. You could punch that into the calculator, get a decimal, but to kind of check your graph, but you don't need to. I'm just showing you that from this particular graph you could not get the x-intercepts or really the y-intercept exactly without doing the algebra. Let's just practice a couple of more. So we're going to find the intercepts. So we're going to say 0 equals to this. That's one of them. And the other one is where you put in 0 for x. Oops, that's not a plus. That's a minus. Okay, so I'm going to do this one over here first. It looks a little bit easier. So remember we have to do that. 0 plus 1 squared is 1. So we have 1/3 minus 5 over 1. Find a common denominator. So that's negative 14/3. Now, over here, just like the last example, I'm going to add 5 to both sides. Then I'm going to get rid of the fraction by multiplying by the reciprocal, because those would cancel. Then I need to undo that square, so I'm going to put the square root, and so I have to put the plus or minus. I cannot simplify 15 any further, or the square root, so now I'm just going to subtract 1. Or, of course, you could write your answer like that. Both are correct. So those are my x-intercepts that, of course, I could not read from the graph. And I don't think I could read that unless my graph was just perfect. So ugly answers, but you can get them from algebra. Let's do this last one about intercepts. Okay, so I have y equals 2 times 0 plus 1 squared. And I have 0 equals 2 times this. Why don't you take a second, pause the video, and see if you can work these out. Then come back and see if we match. So do we match? So here we have 2 times 1 minus 3. So that's negative 1. Here we add 3 to both sides. Now I need to get rid of the 2, so I can just divide both sides by 2. Take the square root, put plus or minus, then subtract 1. I'm going to tell you that's okay, but just want to say that we really don't like leaving our radicals like that. We want to rationalize the denominator, getting rid of the square root in the bottom, so that would be the square root of 6 over 2. So really, mathematically, to make it prettier, we should write the answers like that. And say answers because that's 2 because of that plus and minus.